Hi, here we have an interesting question for students at age 12 or 13 after they study the topic of similar triangles and also area of a trapezoid. We have a square ABCD. This is a trapezoid. This one is also a trapezoid. The area is 4. The area of this is 9. And the question is, what is the area of this right triangle? Maybe I spend 5 to 10 minutes, try to solve the question, and then come back and see the solution. All right, so first thing that we do is to put names for the corners. And we assume that the side of the square has a length of a. The altitude of this right triangle is fg, and the height is h. So we are going to write the formula for the area of this trapezoid. So the area is this length plus this length multiplied to the height divided by 2. So a plus total one is a, here is h, so this one is a minus h multiplied to the height ae divided by 2. So this is 2a minus h times ae divided by 2. Same way we can write the area of this other trapezoid. A plus, this is a minus h, multiplied to eb divided by 2. So this is also 2a minus h times eb divided by 2. If we divide these two together, obviously this part with this part disappears. So we have the area of this trapezoid divided by the area of this trapezoid is equal to AE divided by EB. But this one we know is 9 over 4, so we conclude that AE divided by EB is 9 over 4. Okay, so here what we can do, in order to simplify, we can assume that EB is 4x. In that case, AE becomes 9x. So 9x divided by 4x gives us the same ratio, so this is good. Now we can also write the side of the square as addition of these two. 9x plus 4x is 13x. So A is 13x. The next step, we have to focus on this right triangle. We know that this angle plus this angle is 90 degree, but also this angle plus this angle is 90 degree. Therefore, this one is equal with this. That means this triangle and this triangle, they are similar. Actually, both of them are also similar with the big triangle. All right, so this is what I have written here. GFC is equal to GDF, and therefore these two triangles are similar. GFC is similar to GDF. When you want to write that two triangles are similar, it's very important that the angles that are the same, you put them on the same order. So for example, G in both of them is 90 degree. I'll put them here, here, first one. And the second one, F, this angle is equal to D on the other angle. So if here we have F, the other one should be D. And for this one, C is equal to F. So here is C and here is F. If you write this correctly, then you can write the ratio between the sides very easily. For example, GF to GD, so GF to GD is equal to, here first one, third one, GC to GF, GC to GF. Also, this is equal to FC to DF, but we don't need it here. Okay, so we have proven this equality. We can multiply these two together. GF power 2 is equal GC times GD, but GF is H, so H2 is GD times GC. But GD is equal 9x, GC is equal 4x, 9 times 4 is 36, and we have x times x is x2, so H2 is 36x2, therefore H is 6x. All right, very important information we obtained. Now we can consider the area of this trapezoid, which is equal to 4. So 2a minus h times eb divided by 2 is equal to 4. But we can replace each parameter with its equivalent. For example, a is 13x times 2 is 26x minus h, which is 6x. So this gives us 20x. eb itself is 4x, so we write it here, divided by 2. So 4 with 4 disappears, 2 with this disappears. x2, x times x is x2. x2 is equal to 1 over 10. All right, so we know that the side is 13x, the height 6x, and we know that x2 is 1 over 10. We also know that the area of a triangle is height multiplied to the side divided by 2. So area of this right triangle is h multiplied to a divided by 2, 6x multiplied 13x divided by 2. This with this disappears, it's 39 times x2. x2 is 1 over 10, so 39 divided by 10. Okay, so this completes the solution. Let's see what we have learned. First thing is that for a right triangle, if we draw the altitude, we know that this triangle and this triangle and the main triangle, they are all similar. And if we write the similarity between this triangle and this triangle, we can obtain that h power 2 or ah power 2 is equal bh multiply hc. In some cases, we know the ratio of two lengths. For example, we know that AB to AC is P over Q. For simplification, maybe it's beneficial that we consider AC as Q times X. In that case, AB will be P times X. And then we are dealing with integers in the question, which can be helpful in many cases. All right, this is the end of the video. See you next time. Bye.